This video will provide a brief overview of composite steel beam design and visual analysis. Let's get started. To effectively use visual analysis to design composite beam members, only the steel members should be modeled. The stiffness from the concrete slab or from the member offset should not be included in the model, as these will be automatically accounted for in the design checks. The parameters for the concrete slab, the deck, and the anchors are specified in the design view. Prior to being used in the design checks, the analysis results are automatically adjusted to account for the stiffness of the composite system. If the beam you are designing is unshored during construction, visual analysis can perform the pre-composite strength checks based on the pre-composite bracing conditions that you specify. Also, visual analysis can perform the pre-composite deflection checks. In visual analysis, the member's pre-composite state is defined in the Modify tab of the project manager in the design view. For the composite condition, visual analysis automatically calculates the capacity for the full composite or the partial composite beam based on the strength and the number of studs engaged at a specific location along the member. Therefore, you can design with any level of composite action in the program. In visual analysis, you can fine-tune your design by specifying the steel anchor spacing in multiple regions along the member. The anchor layout is defined in the Modify tab of the project manager in the design view. Composite deflections are calculated using the lower bound moment of inertia as defined in the American Institute of Steel Construction design specification. Since this method depends on the number and strength of steel anchors specified for the member, the stiffness of the system can be affected by modifying the anchor layout. Visual analysis is capable of handling both shored and unshored construction conditions. The permanent pre-composite deflections are calculated and added to the deflections for the composite system, producing the total deflections for the system. In visual analysis, the construction type is specified as either shored, unshored approximate, or unshored defined loads. Two construction types exist for the unshored condition, with the approximate method being more user-friendly but having more limitations, and the defined loads method requiring more input but being more versatile. For the shored construction type, no pre-composite strength or deflection checks are made, no permanent pre-composite deflections exist, the simply supported condition is not required, and camber cannot be considered. Both the unshored approximate and unshored defined load construction types perform checks for the pre-composite strength and pre-composite deflections. Also, the permanent pre-composite deflections are considered. For the unshored approximate construction type, a simply supported boundary condition is required, and the pre-composite dead load is assumed to be uniform. The magnitude of the uniform dead load is calculated based on the self-weight of the member specified in the model view and the weight of the concrete deck and permanent metal deck form defined in the design view. Also, camber cannot be considered. Construction load combinations do not need to be defined for this construction type. For the unshored defined loads construction type, a simply supported boundary condition is not required. The pre-composite dead loads can be defined and are not required to be uniform, and camber can be considered. Construction load combinations must be defined for this construction type. Tutorial videos have been created demonstrating how to design a composite steel beam using each of the three construction types. This short video provided a brief overview of composite steel beam design and visual analysis. For more information, check out the shored, unshored approximate, and unshored defined loads videos, or visit the composite beam design section in the Visual Analysis User's Guide. Thanks for watching and have a great day.